So the 5 on the outside means I'm looking for groups of 5. So I need to figure out what this multiplies to be. So I see that it ends in zeros and a 5. So I'm going to try dividing that number by 500. So I go to my calculator, 212625500. I'm going to try dividing that by 500. And it's 42525. So 42525, and that was 500. So now I'm going to try dividing this 42525. Since it ends in a 5, I'm going to try dividing it by 25, and that works. So 251701. So 251701. Now if I take these numbers, 1 plus 7 is 8, plus 1 more is 9. I know that that's divisible by 9, so I come back to my calculator, divide it by 9. That's 189. And then, so I come back to here, 9 and 189. And if I add those numbers up top again, 1 plus 8 is 9, plus another 9 is 18. So since 18 is divisible by 9, that's divisible by 9. So I go to my calculator, I hit divide it by 9, and it's 21. So I'm looking for groups of 5 again. So 9 is 3 and 3, 9 is 3 and 3, 21 is 3 and 7. 500 is 5 and 100. 100 is 10 and 10. 5 and 2, 5 and 2. So now I'm looking for groups of 5, because that's what this 5 on the outside means. So here's 1, 2, 3, 4, 5 5s, so they come out. And there's 1, 2, 3, 4, 5 3s, so they come out. There's a 7, a 2, and a 2. So there's not 5 of any of those. So they come in here, 7, 2, and 2, and they multiply together. Same with the numbers that came out, and so I will do that in a moment. Now I have x to the 10th. So if I think of it the long way, there's 10 x's, and I'm looking for groups of 5. So there's a group of 5 x's, and there's a group of 5 x's. So those come out. The shortcut way is to take this power and divide it by the number outside. So 10 divided by 5 is 2. 15 divided by 5 is 3. So there's 3 groups of 5y's. W to the negative 20th. 20 divided by 5 is 4. But since it's a negative, it goes to the bottom of the fraction. And 23 divided by 5 is also 4. But there's 3 left over, because 4 times 5 made 20. So there's 3 left over. I put a 5 out here because it's still the 5th root. So now to finish this up, 5 times 3 is 15, x squared, y cubed, v to the 4th, all over w to the 4th, times the 5th root of 7 times 2 is 14, times 2 more is 28, v cubed. So a fairly long problem, kind of hard. Now, number 55, much shorter. The square root of 16 is 4, because 4 times 4 makes 16. And then the negative comes out as an I. So 4i is my answer. So remember, anytime you have a negative under the square root, it comes out as an I. So 56, we have a power to a power, so you multiply those. So you really have 2/3 times 6 over 1. So that makes 12/3, which is 12 divided by 3, so it's 4. So this is 6 to the 4th. And you can circle it like that, or you can go to your calculator and type in 6 to the 4th, which is 1296. So either of those answers would be correct. On 57, remember, if the bases are the same, you add the exponents, so you're really adding 1/2 plus 3/4. So to add fractions, you have to have common denominators, so I multiply top and bottom by 2. So that's 2/4 plus 3/4. So that makes 5/4. So that answer is x to the 5/4. 28, same idea. The bases are the same. You have powers, so really you're going to add these exponents together. So 2/3 plus 3/4, the common denominator of 3 and 4 is 12. So I multiply this one by 3, multiply this one by 4. So I have 8/12 plus 9/12, which makes 17/12. That's not my answer, that's the power. So it's x to the 17/12. On 59, you're going to subtract exponents. So you have 3/5 minus 2/3. So common denominator is 15. So multiply each of the ones on the left by 5. Not 5 on the left. So multiply each of those by 3. And multiply each of these by 5. So that makes 9/15 minus 10/15, which makes negative 1/15. So I would have x to the negative 1/15. We don't like to leave a negative exponent, so really what happens to that is it moves it to the bottom. So that's a 15 on the bottom. And that's our answer on that one. So on number 60, you have a power to a power. So you're going to multiply these. And you multiply fractions straight across. So that would make 30 over 35. And then you can see that each of these are divisible by 5. So if I divide each of them by 5, I get 6 over 7. So this is x to the 6/7. Just so you know, what I normally do if I'm multiplying fractions is I try to cross cancel if I can. And then I don't have to reduce at the end. So see how the 5's on the bottom and the 10's on the top? Each of those are divisible by 5, so that's a 1 and that's a 2. Because 10 divided by 5 is 2, 5 divided by 5 is 1. And then I can multiply straight across, and I get 6/7. So when you cross cancel and then multiply straight across, you don't have to reduce at the end. On 61, remember that this 3/4 has to go to both powers. So it really goes to the 81 and to the 16. So this is really 81 to the 3/4 power and x 16 times 3/4. So this is the easy part. So I'm going to cross cancel on this. 16 and 4 each divisible by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So that leaves me with 4 times 3, which is 12. This 81 to the 3/4, you can type it in your calculator. So 81 to the 3/4 power is 27. So just to show you what that really is doing, remember this, if it's a fractional exponent. So this is my answer, by the way, sorry. So, but to show you what's happening, this 3/4, that 4 means it's a 4th root, and then I cube my answer. So I'm looking for groups of 4. So 81 is 9 and 9. 9 is 3 and 3. Another 9, 3 and 3. So there's a group of 4 3s. So they come out. So there's nothing left on the inside. And 3 cubed is 27. So that's how we end up with the 27. But either way, you can do it this way or you can use your calculator. All right, 62, we're looking for groups of 5. And it says there's a 5 right here. So anytime you're looking for the same size of group and it tells you there's that many, so I'm looking for groups of 5 and this tells me there's 5, this stuff just all comes out. It's like this 5 and this 5 cancel each other off and you're left with whatever is in the parentheses. And that's my answer. So 63 is like the problem we did previously where I take the 5/4 to both of them. So 32 to the 5/4, x to the 20th times 5/4. So the 20 and 5/4, I'm going to cross cancel. Each of those are divisible by 4. So 4 divided by 4 is 1. 20 divided by 4 is 5. So 5 times 5 makes 25. 32, fourth root of 5. So this is 8 times 4, 4 times 2, 2 and 2, 2 and 2. So this 5 out here, though, means I have 5 of these groups. So really what I have is 2 times 2 times 2 times 2 times 2, written out 5 times. So now if I look for groups of 4, there's one group of 4, another group of 4, another group of 4, another group of 4, another group of 4, and a group of 4 this way. So there's 1, 2, 3, 4, 5, 6 groups of 4. So that's 2 to the 6th with 1 2 left over. So 2 to the 6th is 2 times 2, which is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32, times 2 more is 64. So that's 64, x to the 25th times the fourth root of 2. So this one, if you'd have typed it into the calculator, 32 to the 5/4, it would have given you a decimal answer. And I don't want a decimal answer. I want the exact with the square root stuff in it. So if you'd have tried this and seen that it's a decimal, that's when you know you have to go back and do it the long way. If it comes out to be a nice answer, then you don't have to worry about it. And just to show you that 2 to the 6th is 64. All right, 64. So this x to the negative 6th, the negative flips it upside down. Well, it moves the x to the negative 6 down below. So it reciprocates the one that has the negative. So now I have to the negative 1/3. So the negative out here is going to flip everything back right side up. And that gets rid of the negative out here. Now the 1/3 is the same as the cube root. So 125 is 5 times 25. And 25 is 5 times 5. So there's a group of 3 5s. And how many groups of 3 can I make out of 6? 2, and there are no left over, so that's my answer. On 65, I have a power to a power, so I'm going to multiply those first. So 2/3 times negative 3, 1. So that's a multiply. So I can cross cancel those 3's. So 2 times negative 1 is negative 2. So I have 7 to the negative 2. The negative exponent moves it to the bottom, so that's 1 over 7 squared, which is 1 over 49. Because 7 times 7 is 49. All right, so in 66, you're supposed to rewrite this as a fractional exponent. So a is the base, x is the numerator, and b is the denominator. So on 67, x is the base, m is the numerator, n is the denominator. On 68, 11 is the base, 3 is the numerator, the number on the outside is the denominator. And on 69, 70, 71, you're supposed to rewrite these as radicals. So m is the number that goes underneath. A is the power on m, and b is the size of your radical. So on number 70, you're going to have the cube roots of 5 squared. The denominator goes on the outside. The power on top stays with the number. So like on this first one, m to the a, 5 squared. This is going to be x cubed. So I'm going to have x cubed, and then the denominator goes on the outside. And that's the end of your pretest. So if you can do all of these, you'll be golden, ready to go.